area of a circle shard. That's the shaded region on this semicircle here. Let's play. Basically, in the diagram here on the left is a semicircle half disc with radius 5 centimeters. The semicircle is divided into 5 equal arcs: 1, 2, 3, 4 and 5, shown by the dots on the periphery. Determine the area of the shaded region, colored region. This is this. It's known as the area of the circle shard. Okay. Here, this is basically how the method or the approach that you would use to work out the area of the shaded shard. Area of the shaded shard equals the area of orange sector, which is that section there, minus the area of the yellow triangle, which you'll see later, minus the area of the green segment, which you will see later. The green segment will be this segment here. On the left hand side, it's the white segment that we have here. Okay, I'm going to go straight through this as we're going along. Area of the orange sector, the formula for it is theta upon 360 degrees multiplied by pi multiplied by r squared, pi r squared being the area of this circle. 360 degrees is the full circle. You could work in radians as opposed to degrees, but I've taken degrees in this particular case. If you choose to work in radians, make sure you use 2 pi radians and you use radian mode on your calculator or on the on Microsoft Word or whatever you would use. So theta in our case, because we have a semicircle, we have 180 degrees. Now the 180 degrees is divided into 5 sections, 5 equal sections, and 3 of those sections are in the orange sector, 1, 2 and 3. So 3/5 of 180 degrees upon 360 multiplied by pi r squared. That equates to 3/10 of pi r squared, which is 75 pi upon 10. I've left this as 75 pi purely because we can cancel it later and get our solution that we're looking for. So let's move on. Now the area of the yellow triangle that was defined earlier, so that's the section that we need to subtract from the orange sector, such that we can subtract the area of this yellow triangle here and the area of this green segment to get the area of the shard. Now we could do this in a couple of steps. First of all, we'll work out the area of the yellow triangle, which is half the base times the height. The angle A here, you can see on the yellow triangle, and the angle B are equal, simply because the hypotenuse on this yellow triangle here is basically the radius of the circle there, and this one here is the radius of that circle there. So the angle A is equal to the angle B, simply because it's an isosceles triangle. Now the easiest way to work this out is we've worked out that 180 degrees is the area of the angle of the semicircle here, and the 180 degrees, 3/5, 3 sections we're interested in, as this triangle stretches up across the 3 sections. 3/5 of 180 divided by 2, because we have an isosceles triangle there, we get 3/10 of 180, which is 54 degrees for angle A and 54 degrees for angle B. Now the base is 2 multiplied by 5 sine A, and half the base is the same as 5 sine 54 degrees, which is our angle A. Height is 5 multiplied by cos A. Height equals 5 multiplied by cos 54 degrees, which is our angle A. Area of the yellow triangle therefore equates to 25 multiplied by sine 54 degrees multiplied by cos 54 degrees. Straightforward area of a triangle. Okay, let's move on. The second step here is to work out the area of the shard is defined by the area of the orange sector minus the area of the yellow triangle. We've worked out the orange sector, we've worked out the yellow triangle. Now we need to work on the area of the green segment. That's this segment here. As we can see, the area of the green segment is divided in its own little step. Area of the green segment is equal to the area of the green sector, which is this, minus the area of the blue triangle, which will be this triangle within the sector itself. So the area of the green sector is straightforward. Because the green sector stretches over 2 arcs out of the 5, we need to work out the angle there for the sector, which is 2/5 of 180 degrees. 180 being the semicircle 180 degrees. Now 2/5 of 180 all over 360 degrees in order to work out the area of the sector multiplied by pi r squared. This equates to 5 pi as the area of the green sector. Let's move on. Here, the area of the blue triangle now we're looking for is very straightforward, similar to the step that we've done for the area of the yellow triangle, which is half the base times the height. The angle C there and angle D there, basically again, because we're looking at 2 arc sections, it's 2/5 of 180 degrees divided by 2, simply because that is the radius of the circle there, and that across there is also the radius of the circle. So the blue triangle here is an isosceles triangle. Therefore we divide that by 2 to work out the angle C. Now angle C and angle D are equal. That is the same as 36 degrees. Okay, base is equal to 2 times 2 multiplied by 5 multiplied by sine angle C. That's the same as half the base equal to 5 multiplied by sine 36 degrees. Height is 5 cos angle C, the height of the triangle there. This implies that the height equals 5 multiplied by cos 36 degrees. Now the area of the blue triangle here equals 25 multiplied by sine 36 degrees multiplied by 36 degrees. I've kept it like this. You'll see why, simply because it does cancel later on. Try to keep all you're working out as it is. You don't want to put it in decimal form, simply because you'll find it more difficult to cancel later on. So let's move on. The area of the green segment now equals area of green sector minus the area of the blue triangle. Now this is the section that we've already done. The area of the green sector we've worked out to be 5 pi minus the area of the blue triangle, which is 25 multiplied by sine 36 multiplied by cos 36 degrees. That will be our area of the green segment. I'm going to leave the area of the green segment like this, simply because we can cancel it out later on. Okay, now the final method here is the area of the shard, which is what we started off with, equals the area of the orange sector, which we've divided it into, minus the area of the yellow triangle, minus the area of the green segment there on the right hand side, which will give us the area of the shard, which we see as the colored region on our left hand side, or the orange region on our right hand side diagram. Area of shard equals the area of the orange sector, which is 75 pi upon 10, minus the area of the yellow triangle. We take it as it is, minus the area of the green segment, which is 5 pi minus the area of the blue triangle. 5 pi being the area of the green sector minus the area of the blue triangle. Now the area of the shard is equal to 75 pi upon 10. Because we have this fraction here upon 10, what I've done is later on we see 5 pi there. We want to take that and put it upon 10. So we have 50 pi upon 10. That's right, okay. So basically now we have 50 pi upon 10. So what we can do is subtract the 50 pi upon 10 from 75 pi upon 10. We get 25 pi upon 10 minus 25 sine 54 cos 54 plus, simply because minus minus is a plus, 25 multiplied by sine 36 multiplied by cos 36 degrees. Now the 25 sine 54 cos 54 does cancel with the 25 sine 36 cos 36 degrees. You will not, you initially think why, simply because they are they lie on a symmetry between where the cosine and the sine graphs cross. So they're basically on a symmetrical plane somewhere. So have a look by drawing the graph and finding why these cancel. It is quite interesting, and you will see they do cancel. So what we're left with is 25 pi upon 10, which is 5, which cancels down to 5 pi upon 2 as our area of the shard, centimeters squared. Okay, so if you do like this video, I'm sure it's given you an insight into how to work out the area of the shard now. So if you do like the video, please click like on Facebook and like my YouTube videos. Okay, thanks.